Hey everyone, welcome back. In the previous exercises, we recapped a couple of important concepts. For the first challenge, Hello World, we learned how to use the print method to print out a string to the console. For day one, we learned the various data types, strings, integers, and floats. And for day two, we learned operators and how we can transform these various variables of various types to plus, minus, multiply, or divide stuff. And on day three, which is the previous exercise, we learned how to use conditional statements to execute only specific parts of a code depending on the conditions that are met. So for this challenge, we are going to spice it up a little bit more. We'll be using all of the concepts that we have learned thus far and throwing two additional concepts, classes and instances. And the concept of a class and instance is part of the object-oriented programming concepts. And in Python, we use object-oriented programming a lot. So this exercise will definitely be very useful for you. For this task, we have to write a person class with an instance variable age and define the constructor as well as two other instance methods that can be called on these objects or instances of type person. I will skip the implementation detail because we'll be going through them as we go. And at this point, let's dive into it. So the first thing that we will do is define the constructor of this person class. So this constructor is defined on line 2 and line 3. So when we call the constructor, like what we do in line 12, what we are really doing is we are calling this method that is defined on line 2. And in this case, the constructor is used to define a new instance of type person or an object of type person. And currently defined on line 2, we can see that the constructor takes in one parameter. And in this case, this parameter is of type integer. I'll be adding some type hints as we go to prompt you towards adding type hints in your Python code so as to improve readability of your code as well as make it easier for your team members to edit your code accordingly. So for this init method, because the constructor returns back an object of type person, I'll be giving this function constructor a type output of person. And in this case, what we have to do is to check whether if this initial age is less than 0. And if it's less than 0, we will set this current object's age property to be equals to 0 and print out age is not valid, setting age to 0. So let's do just that. So if you notice, in each of this method, the first parameter is self, and this self refers to the object itself which is being created or is being used to call the various methods. So in this case, if we wish to define a new property age on this object that we're defining, we can do self.age equals to initial age. So this is just to demonstrate how we can set a property on this new object that we are creating. So as we discussed earlier, the first thing we have to do is check whether if this initial age input is less than 0. And if it is less than 0, we will set self.age equals to 0 and we will print out age is not valid, setting age to 0. Else, we will just set the age to the input accordingly. And at this step, we have finally implemented the constructor for this class person. And this blueprint, this init method that is defined on line 2 to line 8 will be used to create an object of type person. So the next thing we can do is define the two other instance methods that can be called on all objects of type person. For the first method we're implementing year passes, and in this case, what this method does is it increases the age instance variable by 1. And you can do that by doing self.age to reference that instance variable and do a plus equal 1 to increment this instance variable by 1. And in this case, notice that on line 11 to line 13, we are not returning anything. We're just doing an edit on this existing object's property and increase the age property by 1. So in this case, the type signature of this function is none because it returns back nothing. The next and final instance method we're implementing is MIO. In this case, we're going to practice what we learned in the previous challenge, conditional statements. So what we have to do in this challenge is check whether if the age instance variable is less than 13. And if this instance variable is less than 13, we will print you are young. Now the next check is whether if this age is more than equals to 13 or less than 18. But notice that in this case, if we pass line 11, the age is guaranteed to be at least 13 and above. So there's no need for us to check whether if the age is more than equals to 13 anymore. We can just check whether if the age is less than 18. And if that's the case, we will print you are a teenager. Else, we will print you are old, because at this point, if you pass line 11 and line 13, and you do not meet both of the conditionals, then your age is definitely 18 and above. So in this case, we will print you are old. And that's pretty much it for this implementation. Similarly, for this function signature, we'll be giving this output a type of none, because we're not returning anything inside this method as well. So that's pretty much it for the implementation of this instance method. Let's run this against some test cases. And we passed. And let's submit this code as well. And that's pretty much it. For this challenge, notice that we recap a couple of things. We used the print statements that we used in the first day. We also touched specifically the type integer to define variables of type integers. And we also used various operators to do data transformation. To be specific, actually, we only use one, but we use it on line 20 to increment the age by 1. And finally, we also use conditional statements that we learned in the previous exercise to run only specific code if it meets a certain condition over here. So one additional spice that I would like to throw in is that if you notice on line 2, notice that we encapsulated the return type of the constructor with string quotation marks. And the reason is because when you are at line 2, the Python interpreter is not sure whether if the type person is existing. I mean, we are still going through the class blueprint, so the Python interpreter still doesn't know that this person of type, or this type person actually exists. So to prove that I am right, if you remove these string quotations and you run the code, you will notice that it actually encounters a runtime error where it complains that, hey man, this person type does not exist. And that makes sense. So to prevent this runtime check, we can surround this return type class person with these quotation marks so that it will not be checked by the Python interpreter. And that's pretty much it for this exercise. I hope that this exercise recapped the previous exercises well, and I hope that this video was of value to you. And if it is, please give us a like and subscribe. And if you have any questions regarding this challenge, please feel free to leave your questions under this comment. And with that, I will see you in the next exercise. See you.